Let's consider the implications of adding or subtracting a constant from each score. It should be fairly easy to envision, and I always encourage using the simplest numbers imaginable, although these numbers certainly aren't complicated. If a constant value is added to every score in a distribution, the same constant will be added to the mean, and of course the same goes for subtraction. Let's look at these attractiveness ratings for a male face for a sample of 6 females. So if the 6 females have no alcohol, they rate each face as 4, 2, 3, 3, 2, 3. And of course, that's a mean of 2.83. You add all those numbers up and get 17 and divide by 6 to get 2.83. A fairly direct concept. What if they had a little bit of alcohol? Well, in that case, it adds a constant of 1 to each face. And clearly, this is a hypothetical experiment. It's kind of silly. But 5 plus 3 plus 4 plus 4 plus 3 plus 4 is now 23. I've added a constant of 1. And what has that done? That's raised the mean by exactly 1. Looky there, from 2.83 to 3.83. So a fairly direct idea. Adding or subtracting a constant from each score will add or subtract that very constant to the mean. Pretty cakey. What about multiplying or dividing? Exact same thing. We'll have a caveat on this as it relates to the standard deviation, but with means it can't be simpler. It's a wonderful thing. Every score in a distribution is multiplied or divided by the constant value. The mean will change in the same way. And by the way, you could make the argument, and it's not merely semantics, it's literal, that multiplying and dividing are one and the same. When we divide, we multiply by a fraction. So for instance, if I take half of 4, I'm literally multiplying 4 by 1/2 to get 2, but let's not put too fine a point on that. So if I've got an original measurement in inches of 10 inches, 9, 12, 8, and 11, and I multiply that by 2.54 to get centimeters, I've taken my mean from 10 to 25.4 because I multiplied by 2.54. Of course I did. And of course, who knew off the top of their head there's 2.54 centimeters in an inch? It's not common knowledge, unfortunately, here in the United States. We never did commit to the metric system. But in any case, we're just multiplying by that constant, and of course the mean is multiplied by that constant. We divided 127 by 5 and got 25.4. Of course we did. So a fairly direct idea. We could have divided each of those numbers by 2, let's say. Instead of 10, 9, 12, 8, 11, I could have had 5, 4.5, 6, 4, 5.5, and of course the new mean would have been 5. So fairly direct idea, and you can always do what Albert Einstein described as a thought experiment. Just take 3 numbers, never mind 5. Why 5? Take 3 numbers and just experiment with them. It's always a way to demonstrate, not necessarily prove, but demonstrate these principles to yourself.